Yes, hi Deepak.
So,
Yeah,
can
I'm
you hear me?
audible. Yes. I'm audible
Yeah,
to you.
yeah.
Okay. Screen is visible to you.
Yeah.
So today we will discuss this agenda for
Mm-hmm.
backhauling, 2G, 3G, and
Backhauling.
4G or 5G backhauling.
Okay.
Here, have a look for 2G, 3G, and 4G. So you have a look for a few seconds. Then we will discuss comparative 3G and 4G.
Okay.
Yeah. So if you can check it out in a 2G, so rightmost is the 2G
Mm-hmm.
here. So this
Yeah.
is called MS mobile station. Here in UE, we say in 2.5G or 3G or 4G. So here in this case, if you can check it out, this radio, this is called RAN area. This is called
Radio access network.
radio access network connectivity. So first three architecture, one is mobile phone, second was is RAN, third one is BSC and MSC. So here in this case, cell phone is changed in terms of frequency range. Did you remember we discussed the 900 range, 1800
Yeah.
range? In
Yes.
the
Yes.
same
Yes.
way, for
Yes.
4G, range spectrum is different. The spectrum is different for 4G. So only band is changed in the cell phone, power and all. Rest almost cell phone is the same. So nothing technological change within the equipment. But here, if you can check it out, radio access network. Earlier we were say BTS. Here node B. Now E node B. See the changes. BTS, node B, and E node B. So node B is 3G, E node B is
4G.
4G. So here in this case, RAN area connectivity, technical if we compare, it was like a radius almost 5 to 10 kilometer. Then it was somewhere 8 kilometer. Approximately I'm saying. This is almost less than 3 to 4 kilometer, less than 5 kilometer you can say. And even coming into the 5G, it will be hardly 1 to 2 kilometer. Less than 2 kilometers. So RAN area is getting smaller, but having more coverage, more carrier, dense carrier. So they were able to carry maximum bandwidth. So bandwidth enhancement is continue as per the generation wise. So major changes happened in mobile phone, that is on a spectrum side, that is fine. But RAN area technology has been changed. RAN area technology is changed. So here it was TDMA and FDMA.
Yeah.
Here it was WCDMA. Nowadays, or 3G is almost obsolete. Only older system wherever is running, that is running already. So here it is LTE, long-term evolution.
But even sometimes we see in our phones 4G. It shows us 3G in some areas.
Yes, the older system that is running, they have not removed.
Okay.
Why
So
they have not?
It's like switching.
Yes, switching. So whosoever is the old operator, means if they have 2G infrastructure, so they have nothing obsolete. They have only do the amendment. So single SIM card, like in India, if Vodafone or Airtel, single SIM card is getting switched over. The traffic depends on the signal quality level between 2G, 3G, and 4G. So no further deployment of 3G. Even 2G is happening somewhere in a far-flung area. 2G is still happening because due to distance coverage. But new deployment 3G is not happening. Only 2G and 4G across the globe. So here in this case, RAN area technology has been changed and protocols changed. Here BSC, it is called BSC. This is called 3G in RNC. And did you remember in 2G there was two types of traffic? One is handled voice call,
and the other one is data.
GPRS.
Yes.
So circuit switching it was.
Yes.
And via SGSN and GGSN. So
SGSN. Yes.
So this is GPRS. So packet core. Here in this case 4G, what happened? Here in this case 4G, if you check it out, what is the difference? Here this CS circuit switching is completely removed. After this, all are IP packet core. packet core. CS is removed in 4G completely. CS is removed completely. So all IP packets. So starting from here to here, this is all RAN is your IP RAN. So data is forwarding to the signaling gateway. Data is forwarding to the signaling gateway and forwarded to the internet. So most of the call that is on which protocol? SIP based.
SIP.
SIP based. Yes. SIP based. So in a 4G, you can check it out. In this tower, antenna, controller, all this unit is having within this network, and finally data, after processing the data, forwarding to the here what I will get in this network? IMS system.
IMS system.
IMS, IP multimedia subsystem. So they will handle, process the call, billing, subscriber, HLR and all. So combining as a whole, we say EPC, enhanced packet core. Enhanced packet core. So all IP. So in a 5G, it was as it is like that packet core. Later on, we will discuss what were the changes, architectural changes. So first we understand 2G, 3G, 4G. So major change in a 4G, that is pure packet, all packets. So here in this case, core network, access network, and air interface. Core network, access network, that is RAN, and air interface. So within that air interface, LTE protocol is working. Here it was, for the data, GPRS, or for the call, this was CS.
Okay, switching.
Now, before coming to the next slide, let us summarize activity. Back, what are the options for the air interface? Always wireless. Calling for interface is wireless. Network. There are two things in access network. From here, this side and this side. This is wireless because this is this side connection. This side wireless from here.
Yeah.
Here, what are the options? Fiber or copper, means wired media.
Wired media.
If we talk about wired, then which layer? Because all IP, either layer 2 or layer 3. Because all IP as per OSI rule. Did you get this connectivity?
Yeah.
And here in the core network, still L2, L1 for as a carrier, L2 and L3 interfaces. Because all IP. Because all IP.
Sorry.
But here no L1. Here no L1. So please understand this.
Could you repeat the last part?
Here in a core network, ultimately it's IP. So layer 3 switches and layer 3 router will involve in enhanced packet core. So generally switch plus router, both will be available in the core network. So here in this case, core network, layer 2 plus layer 3, and for the transportation between layer 1 or layer 2 or layer 3, we required layer 1 also. So this is the combination of layer 1, layer 2 and layer 3. But in a RAN area side, we required layer 2, layer 3, not the connectivity of layer 1. We don't require layer 1. You got this one? Same thing. We will discuss once we coming to the 5G side. What was the changes in the 5G?
Understood.
So media.
So I have a question here. Optical fiber. Can we actually get that here also? Is it possible, or is it in 5G?
No, optical fiber is a media. Correct. It could be connected to layer 1 or yes. It could be connected to layer 1 also.
It could be connected.
Layer 2 also, layer 3 also.
3 also. But it starts with L0, right? That's why I was asking.
If we deployed equipment, DWDM.
Okay.
If we not deployed, then fiber optics is a transparent to everybody.
Correct.
Means if it is a fiber optics, I can connect layer 1 device. Layer 1 device. I can connect layer 2 device. Layer 2 device. Layer 3 device and layer 3 device. We can't do mixing.
Understood.
Because
no, for wireless, I was thinking.
No, please, what you said? Wireless?
For wireless, I was asking the L0 concept of optic, the new one.
No. In a wireless, no guided media.
No guided media. Okay. Understood.
Are the representation for fiber of guided media versus non-guided media. So here, if you can check out, this is your guided media and unguided media. But yes, unguided, that is in air, but as a line of sight, both non-line of sight. For backhauling, always line of sight.
Line of sight, yes.
Backhauling. But as a coverage, 4G, 5G coverage, non-line of sight. Got it?
Understood.
So this is a mix of 2G, 3G, 4G at one place, being including all core network, packet network, and backhauling. So this is a very important slide, including IMS system, gateway, HLR. So have a look for deep look for this for a few seconds.
Yeah, that's what I was going checking.
Service provider network is happening like that.
Okay.
So if you can check it out for individual section and connectivity. So let's coming one by one on this is our 2G BTS.
Yeah.
Node B 3G.
3G.
And E node B, this is 4G. So now 2G BTS, you know already it's a layer 1 only.
Yes.
So this is RAN area. This is RAN. This is RAN. This is RAN. But RAN is connected, BTS is connected to nearby connection because ultimately we need to reach over here. So here in this case, here to here, this is my layer 1 bandwidth, SDH. Now FE is fast Ethernet. FE is fast Ethernet.
Yeah.
So here to here, but here to here again, layer 2, but on layer 1, running on layer 1. That is called Ethernet over SDH. SDH is layer 2, layer 1, and Ethernet is layer 2. So once we carry layer 2 over SDH, Ethernet, that is called Ethernet over SDH. The technology is there. SDH is providing this facility. So here in
what is SDH? SDH stands for
synchronous digital hierarchy. Did you remember PDH, SDH?
Yeah.
So here in this case, there are two types of section. Here to here wireline. Here to here is still wireline. But here, this portion, this is radio microwave. Layer 1 micro, TDM radio, layer 1 microwave, wireless. So here to here, mix of wireline and wireless both. Now coming here, FE is Ethernet. So this is layer 2, pure layer 2. GPON, FTTH, they are using here to here and forwarding finally layer 2. This is layer 2. But now this is layer 3, IP/MPLS, layer 3 router. Once router is there, this is layer 3. This is layer 3. This is layer 3. This is layer 3. So every section, we need to find out what activity as per the OSI layer, they are performing, so that we will come to know the protocols. If we know the protocols, then we know how to handle that protocols, how integration will be done. So all this we can find out as per the protocol specific. So see how 2G circuit is transferring from here to here. This is transferring BSC connecting to the BSC. Then BSC to the MSC. So once this call is processed, so this call is forwarded. So it's signal flow basically within the cloud. IP by MSC, but yes, no, this is not.
That's not MSC.
No MSC. So that's SSL 7. Now this is forwarding to the here HLR. MSC, mix of HLR, authentication, LER, did you remember? That's EIR, EIR, all this connected, authentication here. So once you are forwarding any 2G call to the outside landline call, so this call, once authenticated, will be forwarded via here to the PSTN, any outside PSTN call. Any landline call, 2G to the landline, 2G to the landline. So here, this is MSC, you can say, for 3G call also. It will go like that and it will go like that. But yes, 3G to the generally 3G for the network for data we are using. So that way we are handling. So once this will go here for the data, how signal flow will come? After authentication, this data will be forwarded to the internet via packet code. This is the packet code. This is our packet code, SGSN. This is my packet code, PC. Now, if we go for the 5G, not 5G right now, 4G call. So 4G call, all IP. So it will land to HLR for authentication, but further process will not happen. It will be forwarded to the, where it will be forwarded? It will forward it to the IMS. It will forward it to the IMS system. Once IMS will check it out, if this call is transferred to the landline call, so here it will be transferred to the landline call as well. Or if it is a landline, then it will be transferred. Otherwise, it will be transferred to the internet if it is a data. So here, if we talk about 5G, 5G will also come into picture. So not like a separate combination of all 2G, 3G, 4G and 5G. So we need to check it out. In this existing system, how to incorporate or comprises 5G architecture, that we will check it out in a comparative analysis.
Understood.
So here in this case, you can check it out, especially here I'm asking this RAN area is common, nothing a major changes, only changes in the protocol side and number of antennas. For example, there is only one antenna. There is only one sectorial for the coverage for 180 degree, like that way area is covering. Now concept of, because every antenna has some limitation. So if we club antenna 1, antenna 2 like aggregation switch, the traffic at one point, I will be able to multiply my bandwidth rather than one antenna. If I connect my cell phone and I'm sending 10 MB here, 10 MB here, and 10 MB here, then I will be able to send 30 MB at the same time. If like a 2G, in a 2G, if we have only one antenna, so hardly I can able to send 10 MB.
That's right.
So 4G came with the concept that is called LTE. Actual word is MIMO. Have you heard multiple input, multiple output? MIMO?
No, you only told me the other day.
Okay. So simple concept, one sectorial came, depends on the bandwidth carrier, air carrier spectrum. Bits are fixed. We can't increase the bits. That means we follow the example. Okay, a maximum I will able to serve here 10, I will here serve 10. So my cell phone will have multiple input because communication is bidirectional. So multiple inputs, so at the same time multiple output as well. So with this technique, that is called MIMO, multiple input and multiple output. So all my 4G phone having multiple antenna as an input and output. So multiple TX transmitter and multiple receiver, so that I can transmit from TX transmitter, multiple transmitter and receiver and multiple receiver, and at one point we will consolidate the data and we can make a bigger bandwidth. And this technique is MIMO. We got this? How MIMO works. And on this MIMO technique, the protocol we are using, that is called LTE, long-term evolution.
Long-term evolution.
Yes, frame. Did you remember GPRS frame or TDMA frame? Same way there is LTE frame.
Yeah. That's how I remember. Yeah.
1 to 7 some bits carrier was there. Within that, some algorithm was there. That is again R&D level. But here, same way in a 4G, there is the LTE. It's like a protocol, like a format. They carrying signal and data on a multiple input and multiple output. That means multiple antenna having multiple transmitter, multiple receiver within a one phone also, and within a node B or E node B also, tower also. So both are getting connected with help of MIMO, like it's a cell phone. So I can have multiple connectivity here, multiple connectivity for E node B also. So they will connect in a consolidated way with help of LTE protocol in the air. So you got it. What is LTE? Where, which section it will work? After RAN, no LTE, all IP. After RAN means, what does it mean? Means from here, all IP, no LTE, nothing, all IP. So the way you handle the IP, the system doesn't know it's a IP packet or voice segregation. Simply they know this is IP packet. This is IP packet. IP packet means layer 3 packet. So this is combination of 2G, 3G and 4G network. Especially you see in backhauling cases, it is all common to mix of layer 2, layer 3, layer 1. So did you got this architecture?
Yeah, I'm trying to understand. This,
Rather than this big picture, you try to correlate. One layer is the RAN portion, one is your core access network, and one is your core. That way,
that's how I'm trying. That's how I'm trying. Yeah. Anyways, I'll go through it.
So I'm sharing one more reference. This portion you try to understand. This portion you try to understand, and this portion.
Correct.
So this is core. This is access. And this is my RAN.
RAN. Yeah.
This is wireless. This is wireline.
Wireline.
This is wireline.
Wireline.
It could be also mixed of wireless and wireline both.
Understood.
As a carrier. So anybody do in terms of hacking and all or security implementation, we required for end-to-end services, encryption or security for all the devices. So we required extensive NOC or SOC department because you know all our IP, so many equipments, IP equipments are there.
Correct.
And with help of and all are especially connected to the internet. So once you connected to the public network with any public network, then you have two points, entry or exit points. One is this entry or exit point. Another is via SSL7 SICTRAN, and third one is the internal. Third one is internal because these are the private network, closed network. So entering either via geographic, entering into a particular geographical location where network is defined, that is called inside. Outside only two things, via internet or via here. So total 3 points. This is external, or yes, this is internal threat. Anybody came with some malware on a pen drive, laptop, they connected, so that way reaching.
Understood.
So security applications, firewalls is being deployed for internal and external. For generally external firewalls are there. For internals like a cell phone and all, we need to do the scannings for the logical ports that is open. We need to close it. Have you heard Nessus?
I work on Nessus.
You worked on Nessus? Okay. Currently, I use that Nessus network for a scanning of the network.
Yeah.
So with help of Nessus, we are blocking the logical ports and any opening threads like major, minor threads, all we are closing on the monthly basis or quarterly basis. So everybody is doing.
That will give you the VA report. I mean,
correct.
Basically,
VAPT.
VAPT. VA, only VA. PT is different.
PT not giving vulnerability and this penetration test.
That is a different concept, right?
No, concept
to one extent. But it will only see. It is mainly for what you say. You scan all the IPs. Okay, and you do the assessment. Okay, it will give you only the configural reports or community support and all will be there. But it some part of pen test, okay, but not
not in a depth.
Not so, but it is useful for PT.
So internal, that means internal and external threats we can counter. External threats we can counter with help of firewall. So it's not a big challenge, but yes, internal that we are checking with help of this software, security software, analysis, scanning of the network.
You can even use Nmap. I mean, I don't know whether you heard that or not.
No. Here I heard because in project there is a defense project. They suggested to before handover give me the scanning report. So we are doing.
Okay. From the defense project, understood. So there the deployment is there of Nmap. Pentest statistic, correct. Nmap also will be helpful, but here it is an open source. Okay, it is for your network scanner. So here also, like, you can check all your packets and analyze the response, all your TCP. Like if you have the IP, like you just run
any active device.
It on Nmap, any active device, it will give you which port is open on which area, and that will clearly tell you, okay, this is the port open. Then do a deep dive on that. You can easily hack it.
Yes, weak algorithms, any configurational user levels, or
correct.
So here in
yeah.
So here in this case, now especially for the packet core we discuss, EPC, enhanced packet core. So only there was 3 layers earlier, like air interface, access network, core network. Once we coming to the 5G, so see how it migrated, how concept happened first, and how physically we can deploy in the field, and what is the challenges that we will discuss. So in a 5G requirement, they come up with the concept. So before coming to this, we discussed this NFV, SDN.
No.
Network function virtualization and software defined network.
No.
Okay. So before coming to this portion, because this is coming from the cloud concept. So what is happening? Any layer 1, layer 2 or layer 3 device we are forming. So just now we have discussed like any device you can categorize either layer 0, layer 1, layer 2 or layer 3. Correct? Same thing we discussed.
Yeah.
So in any device, every device has 2 functionalities. Every device has 2 functionalities. One is decision making based on the configuration. Decision plus forwarding. First decide, then forward, where to forward. Correct. So decision plus forwarding. So decision is called control, traffic control within the equipment. So controlling and forwarding. You got these 2 words? Controlling and forwarding. So that means every equipment has control plane, means process, plane means process, and forward plane. So any traffic first enters, it is forwarding to the control plane for the processing. Once processed, that data is forwarded via forwarding plane to the outside. It is happening like that. Any equipment, layer 1, layer 2, layer 3, anyone. This is in, this is out.
Okay.
So from factory, equipments are coming. This is layer 1 device, layer 2 device, layer 3 device. If we exhausted the port, and although we required layer 2 port, but we have layer 1 ports available, we are not able to use it layer 2, although it is free. So at every location, I need to install 2 devices. If I want layer 1 and layer 2 device service parallelly, although I have ports available on layer 1, I can't configure layer 2 on this layer 1. Because this is pre-manufactured, defined from factory. You got this line? Every equipment forwarding the data. This is nothing like a transparent. What I will get it, that will be forwarded. What I will receive, that will be forwarded. This is not like that. What I will receive, first I will check it with my control process. Control means policies, what we configured in every equipment. So that means putting some control mechanism inside for the traffic.
Yeah,
so correct. On the basis of this, data is getting processed first, then forward. If I have 2 paths, which path I should follow? Who will decide? That is my configuration.
Yes.
So decision making.
Yeah.
On the basis of configuration. So that
correct.
is who is holding the equipment who has multiple paths. That equipment will decide whether this direction or this direction or both. Did you got my point? So where is decision making point? Within this device? Let it be any device, layer 1, layer 2 or layer 3.
But what if the process is not right? Will it give you an alert saying that, okay, the process is not in control?
Yes, if it is getting too much high, it's taking too much time, I have overloaded, then I'm getting my CPU memory is getting full. CPU
utilization. The utilization.
Yes, process means generally CPU. It will
CPU,
buffer
yes,
memory. Yes, CPU and buffer memory.
Correct.
Virtual memory.
That's what I was asking. So the utilization will shoot up.
Yes, that's why every equipment has capacity, own capacity. Higher the processing power, higher the cost. Higher the capacity, processing power, higher the cost. That's why layer 1, layer 2, layer 3, most expensive device is layer 3, because layer 3 has most means maximum processing power as compared to layer 1 and layer 2. So router is still very expensive device in all telecom devices.
Yeah.
Why? Because router has more CPU power for control mechanism. That's why, did you remember, in a core network, we always use routers only. See this one. We have used routers in the core network only. These round icons are routers. This one.
Yeah.
Most expensive part is this one. Even 1/10 differences, 1/5, 6th differences in a price. All devices are almost 1/10 cheaper than as compared to this router. So reason is this is having control plane, more efficient control plane, big processing power. So once till now you clear control plane and forwarding plane?
Yeah.
Else you will understand further. So nowadays industry is moving till, because what is happening, once you predefine the control from the factory and after supply you can't change it. This is the bottleneck. If you want to do further changes, if any function is not supported, in the equipment, and you want that function, that means you need to buy a new hardware.
That's right.
So industry came with a new concept. We will only manufacture the hardware that is having forward plane, no control plane. Because functionality means control plane enhancement. Got it? Forward plane means only the number of ports you should have. Maximum ports, only, that's it. So brain, ultimately, who will process the new functionality? Brain, control plane. So industry decided we will not put up any control plane in the hardware. My hardware will be the transparent. No concept of layer 1, layer 2, layer 3. Now correlate, you will understand. Switch is having RJ45 port, Ethernet.
Yes.
Router also Ethernet port.
Yes.
So both are RJ45 physical port. How you connect? Via RJ45 Ethernet port, 1 gigabit port.
RJ45, yes.
1 gigabit port on a switch also, 1 gigabit port on a router also. Then why we say this is layer 2 or layer 3? Where is the difference? Difference is control plane.
Yeah.
Control plane means layer 3 protocols is being processed by the router. Layer 2 protocol is processed by the switch. This is the protocol is the decision making process algorithm. Switch will not support OSPF, BGP, L3 protocols. So industry came with the concept, we will produce only the hardware and predefined control plane that was coming from the factory. Now it will not come predefined. Simply, how it will come? One box will come with forward plane. There will be one server outside the equipment that is controlled via software and protocols. They are physically connected and control plane here. This is my C1 controller, this is my C2 controller, this is my C3 controller. So this controller is my software algorithm. So if you want, let us assume C1 means layer 1 controller, C2 means layer 2 controller, C3 means layer 3 controller. So if I will associate push layer 1 C1 controller over here, this is my layer 1 device. If I remove this layer 1 controller and will push C2 controller over here. Now this is my layer 2 device. So what was the difference you observed in this process, what I defined?
I'm so sorry. Could you please the last part?
There is one hardware and one server. Hardware that is holding only forward plane.
Yeah.
There is one server. NMS you can say. So now a
NMS,
smarter new generation NMS. They are holding software defined controllers. Control plane. Controllers is basically control plane. C1, C2, C3. C1 is layer 1. C2 is layer 2. Means group of layer 2 protocols. Group of layer 3 protocols, that is C3. Layer 3.
C3.
If I will associate C1, this is my layer 1. Now in the same equipment, I will deassociate layer 1, sitting on an MS, on the same physical port, on the same physical port. Now I will same physical port connect over here. Now this is my layer 2 device. Now if I disconnect it, same physical port, connect over here, same device is now converted into L3. So what is the interpretation or conclusion you got it from here?
So from here, there is nothing like a bifurcation directly. Forward through forward plan, it will connect all the three layers. Means all the three controls.
Either one at a time, not all three.
Either one, either one at the time. I mean, it depends on the request, what kind of request it is actually. Based on that, the forward. So you don't have anything like direct line 1, L1 to L1 or L2 to L1, L2 or L3 to L3. Here, when you say it will only accept based on the request.
That means if equipment earlier coming as a layer 1 and I need layer 2, although layer 1 has a free port,
correct,
I was not able to use it because it was layer 1 and I was not able to use it.
Correct. But this will give you a free flow, but it will not give at once. It will go based on the request. Like if L1 and L2 are not in connectivity, if L3 is the request, it will be a free flow. It will not have that you have to do a direct connect. How do you say that?
So that means
you told some term for that. I forgot that.
That means like earlier this control plane was predefined coming from the factory.
Correct.
Now this control has given to you. You plan what R&D team is planning. Now you plan and convert it. No need to change the hardware.
Correct. You told some term for that. I forgot the term.
SDN.
SDN. Yes.
This process is software defined network. Means with help of software, you are defining the hardware what you want.
Not SDN. I guess some other. I don't remember. SDN first time I'm doing. NFV.
This is not NFV. NFV. No. For network function virtualization.
No. I remember that. Okay, once I remember.
So this process is called SDN. So nowadays your SDN. NMS is going to be more smarter than current NMS. So earlier NMS was doing only FCAPs, means fault, configuration, accounting, performance, monitoring or supervision. Now adding this controller definition also. Controller.
Okay. The features what you actually showed me in the yesterday's presentation. That six features what you showed.
6 features. Those FCAPs. So FCAPs adding this control plane configuration or software development with help of software. So this entire portion is called SDN. This entire process is called software defined network. So this is SDN. And now let me share with you another example. I developed servers in our offices, correct? And any company who is not an IT company, any smaller factory, for example, I have one factory and I don't want to establish any IT department for my server and all. For my all data, I need internal IT setup.
Correct.
I need to buy servers, I need to hire engineer, I need to, again it got filled up. So again, I need to call upgradation. So all this process I require one IT setup need to hire, correct?
Correct.
So here we don't want to establish any servers and all. We want to buy this IT system as a service. Yes. So software, database, all I buy it space from AWS, Google, Azure. I can buy it in any data center.
Correct.
Only I need internet connectivity. That's it. So I don't require a specialized IT department for server maintenance and all. I require only one small IT guys, technician who can manage the internet connectivity. That's it.
Correct.
So this is called cloud concept.
Yes.
Cloud concept. Offsourcing the services, offsourcing the IT services, IT infrastructure. So infrastructure as a service, software as a service, database as a service. So basically nothing is a concept. Yes. So nothing like a concept, simply concept. Earlier the company who are making their own IT department, now they don't need to establish that IT department. Only simply need to connect some packages on an annual basis. Upgradation could be also overnight within a click. Like I am using 100 MB. Within a click, after placing the order, immediately within a minute, my data will be upgraded to the 1000 MB. But if I want to do the same way, if I have my IT department, I need to buy a hard disk, servers and all. It will take time. So this is concept. Cloud. The cloud is basically concept. NFV concept came into picture. Yes, I will have a space, one hardware, but within that hardware, I can have virtual servers. I will allocate one server to one customer, another customer, another customer. So virtually means on the NMS, I can see total 3 servers, but virtually, physically it is only one server. So concept of NFV, same way deployed like a one hardware of layer 1. And I want to create 2 hardwares for to serve 2 customers, like a big story building, like a multi-story building where one space is one customer, another space is another story is another customer. So I will deploy one hardware and I will create 2 virtual device within that hardware. I will connect 2 customers. So virtualization within the hardware, many virtualization within the hardware. This is called NFV, network function virtualization.
Understood.
So SDN and NFV came into picture. Once they came into picture, 5G starts evolving with concept of this.
Got it.
So now check it out. We will discuss EMBB, URLC, MMTC. What is this? All terms. We will check it out. Virtualization. Now you got it. RAN and core virtualization. So simply same concept, virtualization, like create a virtual equipments within the core, within the same hardware. Edge computing, control and user separation. This is SDN.
SDN.
Control and user separation. Network slicing. Network slicing means backhauling. Did you remember the backhauling we were discussing? This layer, so layered wise requirement. Here it was, how many layers was there? Total 3 layers was there. 3. No, that not that layer.
3 layers. Oh, okay. The access. 3 layers, correct.
It has different condition for latency and bandwidth. It has different condition of latency and bandwidth. It has different condition of latency and bandwidth. In a 5G, correct, they done again more slicings because logical layers has been increased. Why? Because this portion was handling control plus forward both at the same place. So we don't need to check. We don't need to check connectivity between these two. Do we need to check this connectivity? No, because both were connected on the same bus bar. You know bus bar? Within the equipment, on a motherboard, you know motherboard in the laptop, what is happening? So in a motherboard, control plane, forward plane, all are connected in the same equipment. So we don't need to worry about what is the connectivity inside my laptop. Do we care? We don't care. We care only the RJ45 connectivity to my LAN. Same concept is happening. If we separate control plane and forward plane, that means do we require connectivity also? Do we need to consider this connectivity? Earlier we were not considering because this was internal.
Now we should consider.
The way you do the separation, that means again you need connectivity consideration as per the protocols and their limitations. So here in this way, network slicing, service specific virtual networks. So as per the requirement, for the service requirement, we need to do the network latency, bandwidth, protocol, layer 1, layer 2, layer 3, what we need to choose, fiber we need to choose. So all this depends on this network slicing. You decided control plane and forward plane you need to connect, but how you will connect? This is network slicing. How means? OSI not changed. OSI is still the same. Layer 0, layer 1, layer 2, layer 3. Let it be any 2G, 3G, 4G or 5G. So network slicing
only the upgradation has happened.
Yes. Only what we do, we separate control plane and forwarding plane. We do the virtualization, means more software controlled applications. So this all came into picture into a 5G network.
Understood.
So higher bandwidth, once we are moving towards higher radio bandwidth, so definitely RAN also required a big bandwidth to carry. So in a 4G, we came in with the concept of MIMO. So same MIMO came into continuity on a
Yes.
5G
Yes.
side.
Yes.
But yes,
That's right.
new spectrum, new spectrum.
Correct.
Network densification. What is network densification? Can you explain it? In a 2G, for example, in a 10-kilometer radius, we require only one tower. Let us assume. So your cell, did you remember cell? Hexagonal shape we discussed yesterday. So let us assume your cell radius was 10 kilometer and within one tower within that area. So now within that area in a 4G, this is almost we require 3 towers, the radius of 3 kilometer, 3 or 4 kilometer. Now in a 5G, radius again reduced to 1 kilometer or 2 kilometer. So do we require how many? 5 or 6?
5.
To cover that area for 5G. So green is 5G. So tower is getting increased.
Yeah.
So this is called densification. This one. More footprint in a 5G, more hotspots. But yes, one major thing. 2G tower is a big tower. 3G is a smaller. 4G is a smaller. 5G is the most smaller. Hotspot kind, Wi-Fi kind of thing. 1 meter, 2 meter tower is enough for 5G coverage. That's why more hotspot footprint. So network densification. You got it now? Densification.
Yeah.
And this is the major
Yes,
challenge. This is the major challenge in 5G because more densification means more spot you required to fix. More spot you require to fix. That means more connectivity to the power and network, electricity and network. More laying of cables.
Correct.
And more laying of cables in a street or in a residential area. Is it feasible solution? People will not feel comfortable, and every day you are coming with a cable and bunch of cables. This is a challenge, deployment challenge.
Yeah.
More densification means more power to supply, means more connectivity, more cables, more infrastructure. IoT with a low emitting power, millions of device. Because 5G, if giving you 1 or 2 kilometer connectivity, IoT will give 100 or 200 meter or 300 or 500, 1 kilometer maximum. Means I'm referring this kilometer, but yes, less than 5G equipment. So more challenges to connect these devices in a 5G because very soon they will detect it, disconnect it. Very soon they will connect it. So keeping track of all this at the real time, it's a big volume of data. That means more processing power we required.
That's right.
Evolving RAN architecture. So in a 5G concept created DRAN, distributed RAN, centralized RAN, cloud RAN. 3 things. Distributed RAN, distributed densification, you know already, correct?
Yeah.
Densification, you know already. So what they did, what even in a distributed RAN, they are planning within that area, if we deploy more and more tower. So first you deploy the tower with control plane plus forwarding plane. Control plus forwarding. Even in a cloud RAN, they are deciding we will not deploy control. We will deploy only forwarding. Means tower will be there, but only with the forward plane. Then where will be the control plane? Somewhere nearby, some data center will be there. Data center will be there who will process all this control. So like, what is this concept? Software defined network. Software defined network. Now correlating, just hold on. Correlating with this central RAN, cloud RAN, control plane and user plane separation. Ian, in this line. Yes, Deepak. Voice is coming.
Now there was a dead air. Now there was a dead air.
Okay. Now voice. I'm audible to you.
Yeah.
Okay.
No, till that you actually showed the other slide and you were saying this is cloud RAN, and after that I was not able to hear you.
Okay. So cloud RAN here, this cloud RAN, you check it out. This is the part of CPU, like a SDN.
Yeah, that's right.
So here this CPU part of like a SDN. So this is the cloud RAN.
Yeah.
So concept came in distributed RAN, centralized RAN, and cloud RAN. So nowadays people are new concept emerging into the market, like coming the data center control plane, data center towards the mobile application are coming. Create a data center application near to the mobile processing center. That concept is evolving, because if you separate the control plane, that means the control plane and forward plane connectivity processing should be less, because
because
forward plane and control plane earlier they were hand to hand shaking mode. Now they are separated with some link. That means some latency will come,
because it is through third party.
No, not third party. Concern is, let it be third party. Concern is, earlier they were sitting, like we are talking, we are sitting in a room, we can talk without any media, correct?
Correct.
If somebody is sitting 1 kilometer far away, I need to travel there. Let it, my voice should travel or I should travel.
Yeah.
So that means it will consume some time.
Yes.
So that means we should be now take care of the latency between forward plane and control plane also. So things are coming with, everything are coming with pros and cons both. So you got my point. So here latency should be controlled between forward plane and control plane if they are separated. So that we need to plan. This is the major challenge in 5G. So that's why more and more a smaller data center will come into the picture rather than one big centralized data center. How? What is this line means? Let me demonstrate you. Let us assume this is one 5G circle is there. One 5G circle is there. If I will create a remote data center, big data center, then they need to travel in a cloud RAN like that. This is forward plane only. This is forward plane only. Now let us assume in this same case, I can create two data centers nearby 1 kilometer and let it be a big data center over here. This is data center, this is data center, this is data center. So rather than keeping my control plane at this place, I can keep my control plane nearby to this. And then this is then data is going to the bigger data center.
Yes.
So this is called decentralized database control plane. So now due to 5G, densification will not happen only for the tower, but will happen for the data center as well. The smaller data centers to serve the data center. For example, 1,000 Wi-Fi spots, we can club it and forward it to the nearby data center, not a big data center. So in a coming time, data center business is going to be like a boom. The security data centers all due to 5G. Although data centers are in like a big cake, hot cake nowadays, but due to 5G, it will be growing like anything. Why you got this point? Because condition is your control plane should be near to the forward plane as much as possible. This is the thumb rule. Although we separated, but your control plane should be connected with third party external media, but it should be as much as possible near to the forward plane.
Understood.
So here, network slice management, resource reservation, slice isolation, abstraction. What is this? That portion we will. Here in this case, network slicing, did you remember what we discussed? Transport slice, resource reservation, slice isolation is basically whatever infrastructure you created. For example, just now we discussed big data center, a smaller data center to the radio network. So it depends on the application, depends on the port. For example, on the same port, if you are configuring via SDN is the layer 1. If you are configuring layer 3, so in both cases, the protocol will be changed. So as per that protocol, we need to create a virtual path for layer 1, virtual path for layer 2, like a network function virtualization. So earlier, the network, did you remember in this slide, if we configure like a layer 1 over here, so it will be like a layer 1 only. But within the same infrastructure, even I want to create layer 2, layer 3 as well. So this reality we can do with network slicing. So basically,
understood.
Basically, on the backhauling side also, it is giving you the flexibility to configure like a layer 1, layer 2, layer 3 as per your
2 layer 3.
Yes, as per your latency requirement, as per your any control requirements. So all this functionality is giving to you.
Yeah.
So before moving to the RAN portion of this 5G, we discuss the architecture and backhauling. What could be the architectural difference in a 4G and 5G? I hope now you will able to, yes, this wordings maybe not able to remember, but logically, if you compare this architecture of 2G, 3G and 4G LTE versus backhauling, that now you can define it logically.
Yeah.
This word I'm okay. No, you not remember this MBP URLC, that is fine. But
yeah, to one extent, yes.
Yes. Once you will a deep study at your end, then you will come to know this word.
Yes,
but
definitely.
At least once you open this book, open any Google slide, any video, then okay, logic should evolve in your mind. Okay, this was logically that way. So now you correlate.
We need to know the signal flow, connectivity. Yes. Yes. Got it, sir. Got it.
So before moving to this now new backhauling, that is called in a 5G xhaul. Till 2G, 3G, 4G, we were saying backhaul. In a 5G, we don't say backhaul, we say xhaul. So what is the xhaul as compared to backhaul? Why we say xhaul? That we will discuss. So now backhaul means total 3 categorization in the backhauling. One is called backhaul, next is called midhaul, third is called fronthaul. Backhaul, midhaul and fronthaul. You need to remember these 3 things. In xhaul stands for total three things.
Yes. Front haul, mid haul and back haul.
Yes. So now we need to understand what is this backhaul, you know already based on IP, but we need to understand what is mid haul and front haul. We need to understand what is mid haul and front haul. Did you remember we discuss in a cloud RAN like forward plane and backhaul plane processing?
Yes.
All will be in a different. Correct. So earlier there in a 4G or 3G network, in any BTS radio unit, any BTS transmission unit, there was a radio unit, distribution unit and a control unit. 3 things, all in a one equipment only. Means let me come here. Here in this case, radio unit, distributed unit, distribution unit and control unit, all within the same equipment, within the BTS. Then forwarding to the call towards the MSC. Same like we discussed in a SDN, control unit and forward plane. So here in this case, we have 3 things: radio unit, see here, radio unit, distribution unit and control unit, CU.
Okay.
So now they're separated. So all this option, permutation combination in 5G is available, depends on the volume and architecture. Either you can club radio unit or distribution unit, or you can club control unit or distribution unit. So that way, if you separate control unit and distribution unit, this is called mid haul, and radio unit and distribution unit, that is in the front haul. Why?
Understood.
Once we separated this, there is different latency standards we require to maintain.
Correct.
Because earlier in the same thing, in the same equipment, so no latency issue, everything is intact within the same motherboard.
Correct.
Now you can check it out, 100 microsecond, not milli, even micro, 100 in a front haul, 100 to 500 microsecond we required.
Yeah.
1.5 to 10 millisecond hardly we can tolerate. If we can come out from this range, my 5G link will not connect properly. Up latency total 4 millisecond or 0.5 millisecond. You can imagine how much this time bondation is for the 5G connectivity.
Yeah.
So since we separated the radio in a 3 layer, earlier 3 layers were in the same equipment. Now network between RU and DU, radio unit and distribution unit, that is called a front haul, that is having different time standards. Distributed unit and CU control unit, that is having different time standards. And backhaul, you know, EPC, enhanced packet core.
Yes.
The CU and 5G is basically a EPC. So in this case, we separated 3 backhaul, that is called xhaul, because every layer has its own constraint time or latency. You got this line? This is the major architectural change in typical 5G transport. And once we separated this RU, DU, CU, so do we require different network architecture? So that is called network slicing. Now you got it, network slicing?
Yeah.
So here it was written network slicing.
Yes.
So here, why we require network slicing? Because we have separated virtual on a logical and virtual separated was earlier in the same equipment. So this is a major architectural change and challenges. Why? There was one word, did you remember? This network densification.
Densification.
Because too many hardware is going to be installed. So in a bunch, we are making as a one point as a controller point, controller with everybody. Why we did it like that way? Because you check it out, in a front hall, we have very tight timing latency. So if we involve my tower into a processing, it will take time, millisecond or nanosecond. Processing the signal will take some time.
Correct.
So that's why it is a concept. Remove the processing from last mile to the mid hall. बीच में इसको लेके आना है. So that only the last mile should have the functionality to connect and transport. That's it. Processing will start from CU. DU and CU control unit. That's why you see the way you are moving towards right hand side, timing latency is getting easier as compared to 100 and 500. Earlier it was microsecond, now it's a millisecond. So now it is easier, big range as compared to earlier.
Yeah.
Now check it out. This is for your reference. Traditional CRAN, like how we are doing 5G RRU means radio unit, remote radio unit, that is connected. If you combine DU and CU together, then only front hall and back hall will be there. If we
no mid hall.
No mid hall. If we separated like this way, then mid hall will be there. So, so these are the deployment scenario in a 5G. All these three is there. But in an older system, RRU, DU, and CU all are in a one equipment.
But here it is like a permutation and combination, like you said.
Yes. So depends on the traffic flow, limitations, architectural deployment limitations, all this.
Understood.
So this is the major architectural change in 5G. So all game is this, not just separation, is maintaining the timing. This is the major challenge that we will discuss.
So tell me this, okay? People, I mean, I know they have to adapt to the new change on the 5G, but there are some specific areas where the 2G and 3G are, I mean, like earlier we discussed, those, what do you say? Those processes still, the flow and all is happening, okay? And if you go to, like, let's say a remote area itself is like, if I go, still there I not even like 2G is also not that great. Okay. On when you talk about the densification here, right? Obviously, it is for a larger crowd, say for a larger area. So how that is going to correct, like how that is going to adapt?
No, in that area we are not going to deploy in a phase-wise manner. It will happen.
I know. See, if you actually look at it, like, okay, it's been like almost 15 to 18 years, okay, where we have this, what do you say, the new technology, which is actually like, what do you say, the innovative is happening. But still, the 2G itself is not stable, where now we have the 5G. So we are transforming, I know we are transforming to new technology, we are trying to do. But there are like some places where even 2G is still not that great. On such areas, you're saying we will not focus on it, but there could be a lot of.
Look, simple concept is everything is business. Correct. Technology is not driving business. Business is driving technology.
I understood that part. Yeah, I understood. See, now if you actually look at it, they say that with 5G, we will try to get each and every information. We will try to connect the remote areas. We will connect with people. I mean, those who have lot.
Look. This is the fundamental thing on the paper. Whosoever designed to represent in a big, like a discussion on a CEO level, CFO level, or big thinker, R&D level, or some minister level. But actual ground reality is different.
I understood. No, I'm actually talking about the remote, means our militarized.
You see on a 5G videos on a YouTube with a big CEO or CFO. You will, once you will, after understanding all this, once you listen to them, you will say, what is talking about? These are the normal thing, but people are like a hot cake nowadays because this is the new thing.
Yeah, that's why even I wanted to understand, because see, telecom was totally new to me. Okay, that's well. See, you very nicely you gave me, what do you say, the actual flavor of it. Like, see, if somebody wants to study a language, let's say I'm studying the Japanese language here, I need to know the base of it, and you gave me that flavor. Okay, with a very nice slide. Okay, this, and you are making me understand. But when I actually look at it, it is only transforming the new technology and adapting to the new upgradation. Apart from that, there is nothing new. It is just like okay, we have something. I mean, only the speed, the pro. See, cricket is still played in the same way. There is no change. You play cricket in any format. Still, you use the same bat and ball.
There is
only thing.
Simple concept.
Sorry?
There is a word ROI, return of investment.
Correct.
So ROI, if any particular area is not going to give within 10 years, nobody is going to deploy in that area. But government has the obligation to connect every location without seeing a commercialization. Like a BSNL, people say BSNL in a loss. Nothing like a loss. It's a government obligation to connect even in a village where hardly 10 families is there. So 10 families means they are not going to get their ROI in the coming 10 years.
Understood.
But this is government responsibility for the country to connect every location. So they will invest the money, but depends on the minimum site to connect it, not on a luxurious site.
Correct.
So same way.
Yeah, that's what I'm saying. I was just understanding a few things and all, because your training, and there were few big, like you said, there were some big guys who were talking all rubbish. I was listening to them. So when you told me, right, if you get some time, listen to things about all these things. I was going through Spectrum, and this guy speaks about for 1.5 hour about Spectrum in he's trying to use all kind of technical words which is not required.
EO and all, they are defining. Even this 5G, you go after studying this 5G, you will say what he is talking. He is talking in the air.
Correct.
How on the ground it will be happen? It will take another 5 years. Actual maturation, POC
maturation.
Matured stage, that will again it will 5 years at least. Till then there is another thing is going on. Technology may change and it will not go 4G 5G in that way. Reason being, people are talking. Have you heard there is a new statement that Tesla has given? Elon Musk has given. Have you heard
regarding
satellite? Just now we talked about satellite, internet from satellite, internet from satellite, and it's a big bandwidth. Correct. So if it happens like that, then no need of this 4G 5G kind of deploy so much expensive fiber optics and all.
Correct.
No requirement. No requirement of any external power bank, just AC, security and all. So like in a TV, like in India, we are using a Tata Sky and all at our home. But due to less bandwidth, we are not switching to the satellite side because satellite has a limitation. If satellite has given the bandwidth like 100 MB, 200 MB, 100 gigabit, 400 gigabit, why I should go for the fiber? What Tesla has given, like they are preparing to launch in India, like a satellite bandwidth having 100 MB for its subscriber. Can you imagine that revolution? All broadband player will be out.
Yeah.
Same way, like once Tata Sky all came into business, local cable guys, MSO guys, that is gone. Their business is almost half.
Correct.
Same way it will happen. So technology, only 5G and all fiber optics will be there where we required bandwidth in a gigabit. Otherwise, all a smaller thing will be switched on to the satellite. So let us see what will happen. So that's why once you see, means you can't predict what will happen after 5 years. So they are all talking on the air.
Understood. Because even if you look at the business here, right, they couldn't start the business here. They had to go to Singapore, and from there only they had to start it. From here, SB was already not supporting for 5G. SoftBank was totally against. You won't believe they had to go from here to Singapore. From Singapore only they launched the complete 5G project. My friend is a HR. Okay. He's actually the telecom. What do you say? He's a telecom recruiter for 5G.
Sometimes I really fascinate. Okay, what is talking? I should go with. I should also in cash. But sometimes, yes, I don't know. After 1 year, 2 year, what will happen? Some layoff will happen. Okay, that project is not success. Close it.
No, they are actually doing a very big in India right now. If you look at it, they are moving the business from here to India. They have already started in Bangalore. Okay, there with 1,000 people. The current strength is 1,000. Yeah, next year by 2020, by this year, they are planning to have another 1,000 people there, and 300 people will be working only for 5G telecom. अभी start हुआ है. Bangalore में चल रहा है ये, Bangalore, Hyderabad, and Pune. Rakuten is actually like they started this. My friend, because he's into telecom, so he's completely doing the recruitment and all. So that's what he was telling me.
Sometimes I really fascinate, but again I thought अगर यार होगा क्या पता चला 2-4 साल बाद फिर चलेगी कंपनी, you come back. और आपको इधर टेलीकॉम इंडस्ट्री तो मालूम ही है क्या सिनेरियो है इधर जॉब का.
नहीं, ये पूरा जो डेटा सेंटर है ना सर, it is in Bangalore. So complete ये जो Rakuten का डेटा सेंटर है, so they have 7 businesses. One is into like their e-commerce, एक travel है, अभी टेलीकॉम का नया इन्वेस्टमेंट है इनका. Okay, apart from that they have like ऐसे 7 business चल रहे हैं. So जबरदस्ती आई एम टेलिंग यू, ट्रैवल के बंदे को उठा के टेलीकॉम में फेंक के उसको बोले कि भाई जस्ट गो डू ट्रांजिशन, लर्न. यस, because my friend, he also came to Japan like almost 1 year back, and he got recruited 2 months back only. And so before that he was supporting through India. वो इधर ही है क्योंकि उसकी वाइफ भी इधर ही, जैसे मेरी वाइफ आई, उसकी वाइफ भी इधर ही है. तो he came here. हम लोग को लैंग्वेज की वजह से they were not ready to like take us. So somehow he was part of Rakuten Travel का third party में काम कर रहा था, recruiting people from all over India, South Korea, North Korea से. He was China and all he was getting. So there one big shot guy from Rakuten, he told, okay, you're doing good. We have a new business. I'm actually moving to Singapore because I also don't know anything. We need new HRs and new recruitment हो रहा है. So we want somebody like you because we are doing for India also. That's when he got opportunity to. That's when he moved.
Oh my God!
That was a lucky chance for him.
So
that guy only.
Because मैंने भी try करूँ. Sometimes I really find it fascinating. I should switch on. I got this clarity. मतलब है उसको encash करे जो knowledge है. But sometimes I really thought कि यार 2-4 साल बाद अगर इन्होंने change हुआ तो पता चला जाएंगे किधर? Because they will gone after 4-5 years. Like what happened at Etisalat 7-8 years back. Etisalat came here. They deployed, and after 6 months, everybody gone, and all employees were on the road.
Yeah, true. वो रहेगा सर. I mean, अभी तो जोरों शोरों से कर रहे हैं recruitment, इंडिया में करते रहे हैं. इधर तो नहीं कर रहे. इधर problem क्या है बोले तो people are running away from this business.
Okay.
And all the guys who are here working in data center, from where are they? This is the funny part. You're going to listen. IIT BITS Pilani.
Oh my God.
All these guys are IITians and BITS Pilani guys. And max they are working here for 6 months or 1 year. उसके बाद यहाँ से सीधा भाग जा रहे हैं.
अच्छा.
You remember I gave you 2 names.
Yes.
Yeah, they are the core guys.
So right, for today, any query or any question you can please ask, or we can repeat.
No. As of now, nothing. Thank you.
Thank you, Deepak.
Thanks for watching. Don't forget to subscribe to our channel.